Okay, so in today's session, I will introduce for you what should be done in the project. Some of you have already sent me the projects I want to work on. Please, for the remaining students, if you didn't select yet a project, I will suggest here several ideas. If some of these is interesting for you, let me know. And if you want to work on another research topic, it's fine for me, just it should be related to the course content. So just send me your proposition so I can tell you if we can go for it or not. Okay, so to start with, the project will consist of a paper. So we'll introduce you how to write a research paper, and the presentation that should be completed in groups of 2 to maximum 3 students. If you wish to work on your own, it's fine for me also. It will give you an extra credit. And please, the work should be proportional to the number of students. So if you have 3 students per group, then I expect that you should work more. So you should divide the load between students to have your final report. Now, concerning the topics, they should be scientific or technological, so related to science and technology of energy, and should be extensions to what is covered in this course. So I will first go over some possible potential research projects that we'll discuss together. And as I told you, try to finalize your choice as soon as possible, because you are expected to start to work on your project. So within 1 month, we will start to do the presentations together, and the presentations will constitute a very important part, because this will allow us to discuss new ideas that are related to the science and technology of energy. So you will see that when we go through your projects, we'll go over the main ideas of the course, because we'll tackle renewable energy, we'll tackle different techniques to store energy and to convert it from one form to the other. Okay, so now to start with, I will consider some possible topics. The first one is electrochemical capacitors as a means of energy storage in electric vehicles. So we know that energy is present in several forms. You can store it in mechanical form, you can store it in chemical form, in electrical form, in potential form, okay, potential gravitational or kinetic energy. So um, changing the energy from one form to another is very interesting and had a lot of applications. So the first one of the possible application is to chemically store energy and then to convert it to electrical energy in vehicles. So in this topic, when we consider electrochemical capacitors, which is also referred as electric double layer. Uh, um, this application appears in electric vehicles application. In this case, we will change form of energy from chemical to electrical, and it will be nice to study the design of such system and to think about what can be improved in the design. So I encourage you in any of the topics to do first a literature review. In the literature review, you will read several papers related to the topic. And when you do these readings, you will come up with a certain conclusion about a certain gap. Yani we call it literature gap. So always you have some aspects that were not studied completely or that are under continuous research. Of course, this is not a master study. Maybe you will not be able to come up with an innovation, but you can just suggest one small modification that can help into the increase of effectiveness of the topic you are working on. Okay, so one of the first application is the electrochemical capacitors. Another one is thermal storage. Thermal storage is very important because sometimes we'll see that in some cases energy is in excess. So let's say in a country where which is exposed a lot to solar energy, when you have a solar system, it will allow you, let's say, to heat, for example, water for shower, to heat water for domestic application, but you have an excess of energy that if you don't store, you will lose it. So we use in this case in conjunction with the solar system, we should use another system linked to it that can store the energy when it's in excess. And for example, let's say we have a solar system. We have, and the solar system has as a purpose to heat water. Okay, so what we do, we can circulate water or any refrigerant in the panels. So the panels will be exposed to the solar energy. As the fluid will pass through the solar panels, it will absorb this heat. Now, it can be any refrigerant of good absorbing properties. This refrigerant will circulate in a closed path. Okay. Now, this path of circulation can be linked to several other passes. So what we mean by this, you can connect through a heat exchanger the path of this refrigerant with water. Okay, so you will pass water in a heat exchanger. As the refrigerant will pass through the heat exchanger, it will release heat to water. Now, this water circulation will depend on the needs. So this track of water can have several paths. You can have a path for domestic use. Okay, so if you have peak hours of consumption of water, then maybe all water will go through the domestic line, which will be used for shower, which will be used for all domestic and house applications which needs hot water. If you are in hours where we don't have a lot of occupancy and we don't need a high flow rate of hot water to circulate in the space, then we can have a control system, or you have valves that can open and close to switch the path of water. So you can, when you don't need this hot water, you can take it through another path, and then it can be used, for example, to you can take it to a reservoir that will store this water until needed. Okay, in general, because with time you can lose this heat in a reservoir, what you can do is that you can pass this water in what we call a thermal storage system. The thermal storage system is characterized by a high capacity, so it can absorb a lot of heat, plus it can, if you want, it will release it in the appropriate time, so it can store it and keep it until needed. Okay, so we have several possibilities for thermal storage, and they can be used for in heating applications, in electrical applications. So for example, you have thermal storage that is used for electricity generation by using power from the sun, even when the sun is not shining. What do we mean by this is that the energy that is collected from the sun, any excess of this energy will be stored in a certain system, and this system will deliver it when appropriate. So in hours where you don't have the sunshine and you need this energy, the thermal mass will restore it for you. And we have different types of thermal storage. You can work with PCM, you can work with materials that has the high storing capacity. So for example, in such applications, we can concentrate solar plants that can capture heat from the sun and that will store energy or in water or in molten salts or in PCM or in any other fluids. This stored energy will then be released at the appropriate time to generate electricity, enabling then the use of solar energy even after sunset. Okay, so the storage is very important for efficient use of renewable energy. Another topic of interest is wind energy. So we'll see that this will be one of the important topics that we'll deal with, because we will consider different types of renewable energy. One of them is wind energy. You have a lot of systems. You have systems with vertical axis. You have systems with horizontal axis. You can go if you are interested into the aerodynamic field, you can go deep into the design of blades to know how we can enhance their profile to obtain better performance of wind. So a project can be to study the blade profile, to write the mechanical equation, and try to see how we can enhance the performance. You can compare different configurations of wind plants. So you can have you can compare the performance of the effect of the number of blades. We'll see that the number of blades will affect the performance. You have some turbines or some wind energy with 3 blades, with 4 blades. What will be the difference? How the number of blades affects the performance? So you can have different topics related to the wind energy topic. Another topic of interest is coal power plants. We'll see together, as shown in the outline, that one part of the course will study fossil fuels. And fossil fuels is one of the most used sources of energy nowadays, but it presents a lot of disadvantages. It's contributing a lot to the global warming effect. Plus, we have a lot of shortage also. So in some years, if the trend of energy consumption continue in this way, we will end up with not having any more fossil fuels. So we need to start from now to think about other alternatives. So one of the strategies is to use also different than fossil fuels, is to use coal power plants, which dominates the global energy area because it's abundant. It's now affordable more than a fossil fuel, and it's widely distributed across the world. And coal also is less harmful for the environment. So when properly handled, it's one of the cleanest type of fossil fuels available today, not like the fossil fuels that we are relying now on. So like diesel and other gasoline, so which are producing a lot of harmful products. Now, another also possible topic is to assess the current CO2 capture and storage in power generation and industrial usage technologies. So we have seen that we are relying a lot of fossil fuels. So it's true that we are trying to switch to new alternatives, but still the dominant mode of energy production is fossil fuels. This is why to try to reduce the bad effect of using fossil fuels, we can study some systems that will be able to capture CO2 and store it and produce from it power. So in this way, we can prevent the harmful effect of CO2. We can reduce global warming, and at the same time, we can benefit from this stored CO2. We will transform it in a certain way and produce from it power. So this technology is called capture and storage, capture of CO2 and storage in order to use it after for power generation purposes. So as a brief description, we know that emissions of CO2 have been increasing a lot with time, and we have reached a very huge increase of these emissions. This is why we are trying to reduce their bad effect by coming with technologies that can profit from emissions of CO2 by first capturing it, storing it, and then using it for energy generation purposes. So until now, we have each year a rise in the global average temperature, and we are expecting that if the trend continue, we can reach up to increase of 2 degrees by 2050. This is why what we should do, we should limit these emissions. And since we are not able to not use fossil fuels, we can control these emissions at least by using such strategies. So This is a good idea because we will transform a source that is very harmful to the environment into a power generation source. Now, another application also that can be a possible topic is the potential to reduce CO2 emissions by using engineered microorganisms. If you have, if I think no one of you is a chemical engineer, but in case one is interested in chemical engineering, we can do this topic. So you can see that this course is involving several fields: mechanical, electrical, and chemical engineering. So a part of the push to reduce greenhouse gas emissions produced by burning fossil fuels will be to develop a greener way to extract biofuel from bacteria. So the idea will be to genetically modify a bacteria in order to consume carbon dioxide and produce the liquid fuel, a liquid fuel which can hold great potential as a gasoline alternative. So in this way, you can also reduce the level of CO2 while producing energy. Another topic will be battery technologies for plug-in hybrid electric vehicles. You know that we have a very important trend nowadays to go from cars that are working on fuels to have cars that are just that can be charged in electrical way. So this is a very important field, and it's in continuous development, and we have a lot of research that is performed in order to enhance, if you want, the performance of these cars and make them competitive to replace cars that are supplied with fuels. So we know that in this case, if we want to use electricity to supply a car with energy, we should have appropriate energy storage systems, because the car might need to move a very long distance before being charged again. So this will depend a lot on the development of battery technologies that can work for a very long period and can be charged over long distances. So energy storage systems that are usually batteries will be essential for plug-in hybrid electric vehicles. And in this case, we can use these batteries to power an electrical motor that will use another, if you want, at the same time, we can work on, at the first stage, on hybrid vehicles. So the vehicle can be implemented with fuel, but also can rely on batteries. In this way, we can avoid the shortage. And if let's say the battery cannot handle a certain distance, and the remaining part you can rely on fuel, and this will be like a transition to completely electrical vehicles. So this technology is under development and is very interesting if someone wants to work on it. Another possible topic is Stirling engines. So here, this is a thermal application. So we will study together in this course several thermal cycles, okay, several power plants. We will learn how to combine these cycles, and sometimes you can use combination of several cycles to have a certain complex power plants in which you can use energy that is lost to be used for heat recovery in another place. In this way, you can increase a lot the efficiency of the system. So Stirling engine is a heat engine that will operate by cyclic compression and expansion of air or other gases at different temperatures. In this way, in this topic, you will go into detail with thermal cycles, and you will do an application of one of the main parts of this course, which will be the study of thermal power plants, and you can see how we can improve their efficiencies. Also, another possible topic is smart grids. Smart grids also is a very original topic that is under continuous development. and especially in developed countries, it has reached a high level of development. So a smart grid consists of an electrical grid, which includes a variety of operational and energy measures, including smart meters, smart appliances, renewable energy resources, and energy efficient resources. For example, in some countries, if you have a house equipped with renewable energy, let's say you have a lot of solar panels on your roof and you have excess of energy, you can sell electricity to the state. So you will have like a system that when you need electricity, you will in your bill you will pay a certain amount, and at the same time, if you have an excess, you can give it to the state, and then your bill will be reduced. So in this way, you can contribute to the production of electricity of the country. So this is very important because this will encourage the use of renewable energy as first as an intermediate step to be implemented with other resources of electrical energy, and with time, with proper development, we can reach in some countries the state of relying 100% on renewable energy to produce electricity. This will reduce a lot first the cost of electricity in a country. So you know how much electricity can affect the country balance. If you just take the example of Lebanon, so the electricity problem in Lebanon has caused a lot of economical deficit, and if we can solve it, then we can get rid of a very important problem. So smart grids is a very interesting application that should be implemented to all countries if possible. Now, also another topic that can be worked on is hybrid power plants. Is hybrid power plants the future for intermittent renewable energy resources? So as we said, sometimes in transition phases, when we are not ready to completely switch to renewable energy, we can combine renewable energy with current sources of energy like fossil fuels power plants or power plants relying on, let's say, coal or nuclear power, etc. So when you combine different sources of power, you can increase the efficiency of both systems. And we'll see together when we study the cycles that by combining different cycles, you can increase the overall efficiency of the cycle. So hybrid power plant will often contain a renewable energy component, like let's say PV solar system, photovoltaic solar system, or also it will also be implemented with a second form of generation or storage, like a battery storage system, or sometimes a system relying on fuel consumption to produce energy. So this is additional topics for people who didn't decide yet on the project topics I want to work on. Now I will move to the content of the project. So
okay, sorry.
Project include? Yes.
Sorry, my voice is cracking.
Yeah.
Can you ask some questions, or would you like us to postpone it until you go through the whole thing?
No, of course, interrupt me whenever you want. Whenever you have a question, you can interrupt me and ask.
Thank you so much. No, the flow was amazing. I actually have one question, which is maybe a confusion on my part, so excuse me ahead of time.
Yeah.
When we said the project,
yeah,
and the PowerPoint presentation, so there are definitely the PowerPoint and the project. So the PowerPoint presentation is about the project. It's not too distinct.
Of course. You have a report, a written report. Yeah. Okay. Yeah. So you select a topic, a project topic. You have to write a report. This report should be in the form of a paper. Okay.
Of course.
Okay.
Of course.
And when you do this work, because you want to present it to your colleagues, you should put it in PowerPoint form.
Yeah, absolutely. Okay. So last time we went through on Moodle a list of ideas, project ideas, and I think some of us chose, and now we have these. So this is further choice.
Yeah, of course. Of course,
okay, so
because a lot of students
okay,
didn't
okay.
select the topic yet.
I
So,
actually like,
and I wanted you to see the link between the topics and the course material.
wow,
So I
okay,
selected several topics very related to the course material. And then
okay.
when we expose them and discuss them, will be in another way, explaining the course material content in a more interactive way.
Yeah, absolutely. So it's not too late for us to change. If I like something here, like
Yeah,
smart grid,
of course. If
it's
if
yeah.
you are interested more in you can change, of course.
Thank you so much, because smart grids, the experience that Egypt had, they introduced it in 2015, and then what we're trying to do here through the new electricity plan, I think there's, my heart is there. I know some about it, and I'd love to pursue it more.
Okay,
From a
great.
technological.
So just tell me that you changed
Okay,
your mind, okay?
I will.
And please reserve the topic you want, because we cannot
Yeah.
have two groups
No.
working on the same project, okay? So
Absolutely.
whenever you decide, tell me that I want to work on this, because I'm taking notes, so we have different projects.
Absolutely. I'll do that the minute we're done. One last question. It's regarding number 4, coal power plants. Now, I found what you said is quite intriguing. To me, through the, I don't know, plus 10 years, we're always, advocating against coal. And Europe, it's through its Green Deal, is going against using coal. But then you said when properly handled. Can you tell, what do you mean when properly handled?
Yeah, exactly. Exactly. Look, you have several chemical processes that can be that can take place to transform it from one state that is harmful for the environment to another state that is fine. It needs some treatment before being used.
Yeah. Okay. Got it.
Okay.
Thank you so much.
If anyone is interested in this topic, he will talk maybe about what is the possible treatments done so that it can be used in a less harmful way.
Yeah, and whether it's feasible for the investors, basically, at the end of the, it's beautiful. I'm not going to jump into
any project considered. So I advise you in any of the projects you consider to also take the economical aspect, because any topic can be very interesting, can be very original as idea, but when it comes to implementation, it might not be economically viable. So in a lot of cases, the economical analysis can be a block for a research idea. For example, for photovoltaic systems, when we started to do research about photovoltaic systems, the cost was very high and the efficiency was limited. So no one opted to implement photovoltaic systems until we come up with new technological advancement to enhance their performance and make the cost lower, so that the project of these photovoltaic systems is economically viable and can be implemented by investors.
Amazing. Thank you so much.
Welcome. Any other question? Okay. So now for the content, okay? So in general, I know very well that to write a journal paper, a research paper, it's not something simple, and sometimes it can take a master's thesis, it can take 1 year. Of course, I don't expect this from you. You will not have to do any research paper in general will involve experiments or will involve numerical simulations. Okay, I don't expect this, but some projects, if you want, in some topics you can do some simulations, and I will illustrate, for example, which topic you can do some simulations, and other topics you can do economical analysis. So I just want in each project to have a small aspect that show your contribution. Okay, so first, in any research paper we write, we should have first an abstract. In the abstract, we will summarize the project content and its main finding. As I told you, I know maybe that you will not be able to answer completely a new a research problem and to find the solution for it, but at least you will tackle any any challenge, or you will propose any small strategy to enhance the performance of the system you are working on. So in the abstract, you will describe your project and the main finding you were able to reach through your research. Now, in the introduction part, this is a very important part. Okay, you will do literature review. Literature review is essential in any research work because you should know what was done before to know what is the originality of your work or what contribution you can make. Okay, so for example, it doesn't have to be a very important innovation. It can be just a small contribution. So let's say, for example, you are studying the effect of the problem of electricity in Lebanon, and you want to solve it. Let's say one of the possible topics, what can be the solution for electricity problems in Lebanon. So to know what to do, what the first thing to do is first to look maybe at other countries. What were the strategies done in other countries? So let's say in the literature review, you look at all different strategies already used before to solve for electricity problems. So one of them, for example, is to substitute fossil fuels, let's say, techniques by using industries relying on gas. So one possibility is to import gas, for example, from for Lebanon. One possibility is to import gas from Egypt, for example. Okay, you can also consider other strategies is the use of renewable energy. So in many countries, let's say we can rely on solar energy. We can rely on wind energy. We can rely on hydropower. Of course, if you are taking a certain application, so when you talk about Lebanon, already this is the originality. You are trying to implement strategies used also in other parts of the world in your country, and you should know which one is the most convenient one for you. Okay, so the first alternative maybe is hydropower. Lebanon, for example, will be will offer you a lot of facilities because you have water largely available, you have wind also, you have solar existing in the majority of time. So all of these strategies can be implemented to Lebanon. Whatever, if you are taking in other countries, maybe this will not work. So depending on your application, you can, if you want, select the convenient solution. Now, this is for example, a practical subject. You might go to a subject more into design. So let's say you want to improve the design of solar system. For example, if you take this project, when you go to literature, you should state then, for example, what were the different strategies used in solar energy. So you can expose, you have photovoltaic cells, you have, let's say, solar panels. Okay, you have different configurations of solar panels. You can use let's say, for example, what is the difference between a panel with a double glazing, or if you have heat exchanger within it. So you have a lot of configurations. You can expose all of these configurations and try to compare their efficiencies in literature and what were the improvement done previously. And when you study these configurations, you might identify, let's say, a certain gap. Let's say we were not able to, for example, to exceed an efficiency of, let's say, this number. And you can think about what can be the strategies used to improve this efficiency. Maybe you will say, I want to combine, let's say, two systems, or I will use, let's say, one of these. For example, okay, one of the limitation of photovoltaic systems is that you cannot exceed a certain temperature at the surface. So you have to continuously cool the surface, which will limit the efficiency because you want to reach high temperature to absorb energy, but you cannot exceed a certain temperature, let's say 70 degrees. Okay, you should not exceed it because this will affect the mechanical properties of your system and it might destroy it with time, so it will not work. So what you can do then, because you continuously need to cool, if you just cool your surface and you don't benefit from the energy that is extracted while cooling, then it will be a waste and your efficiency will not be able to be improved. So this system, if combined, let's say, with any heat exchanger, in which you have a flow of water or a flow of refrigerant, this energy that is extracted from the surface to keep it in the corresponding limit can be used for other purposes, can be used for heating applications. So this is what we call heat recovery. So one of the main strategies to increase efficiencies is to use the heat recovery concept. So this is an example of ideas you can use. You have a lot of possible ideas you can take. Okay, so this is what we mean by the literature. Each topic will be already investigated before, so you can do like how to do this review. You can use the AUB libraries. You have access to AUB libraries. You have a lot of you can access very important journals, Elsevier journals. You have energy and building, solar energy. If you have also, for example, energy conversion and management journal. So all of these, you can access them. Okay, and just you have to put 2-3 keywords related to your topic. You will obtain a high number of journal papers already present there. Now, how to know which one are relevant to your topic? It's enough to read the abstract. So first, by just reading the abstract, you will know if this is interesting for you or not. You can collect, so at least in a literature review, at least you should have nearly 20 papers, because this will give you an overall idea about the topic. And once you are done, then you can put a plan for your work. You know, I detected this gap and I propose a certain improvement. I propose to do this, let's say, to overcome it. Of course, maybe I will not be able to do a complex modeling. I will not be able to do a very complex numerical simulation, but I can put what is the model I propose. Let's say if I implemented, let's say, a small modification, I can physically describe how I consider that it will affect in a positive way my system. If you are taking a practical analysis, a practical topic like the electricity problem in Lebanon, you will be able to do some calculations. This also will be interesting. You can do an economical study, for example, to assess what will be, let's say, the initial investment if I want to implement solar systems. Let's say I take a building. For this building, I can study if I want to implement solar system, what are the costs, what are the benefits. So I can study the payback period. I can, for example, another possible topic is green buildings. You have a lot of strategies that can reduce energy consumption. So if you can just, for example, if you have old buildings in Beirut, let's say, in old buildings, glazing was single. You don't have, let's say, a lot of appropriate shading. You don't have solar panels. So you can take any old building. For one topic can be green buildings, how green building strategies can reduce the energy consumption. So this is a possible topic also. In this case, this is much more practical. I think if you have taken already an HVAC course, you know how to use Hub, for example, or how to use Design Builder. So I don't impose on you any of these, but in case you have a knowledge, which is certain simulation software, and you wish to do a certain, some numerical simulations and present results, this will be also of interesting, okay? If not, you can study the results got from literature, do their analysis, which will help you in proposing advancement for the topic you are working on. Okay, so if I go back to the example of green buildings, for example, you can put several strategies. Let's say I can replace single glazing by double glazing and see how this will affect the total energy consumption in my building. I can change, if you want, I can add a layer of insulation for the envelope.